All right. Well, good morning, folks. I hope you everyone had a nice weekend, had a nice 3-day break, and hopefully you're ready to go and finish out this semester. And so I just want to remind you, folks, we're going to be finished up with this chapter. Hopefully today, I think we will get done with it today. And then what I'd like to do is, remember I pointed out to you that the exam will be this Friday. And so what we're going to do then is, if you look on Classroom, I have posted the material for the new chapter, and the new chapter is going to be chapter 14. So we'll finish up the semester by going over chapter 14. Your final is just going to be an exam on chapter 14, and it'll be only on the material that we can get through. Hopefully we'll be able to get through all of the material, but if not, then again, your exam will only be on the material that we actually cover in lecture. Okay. So please take a look at that material. I'd like to go ahead and hopefully get started with that tomorrow. If not tomorrow, then we'll get started on it. Next week. So what we'll do is we'll start chapter 14 tomorrow. My hope is that we will finish this chapter today, start with chapter 14 tomorrow. Thursday, we will meet on Zoom, and we'll do our review session at that point. I'll post the review, I'll post the Zoom meeting for you. And so plan to meet on Thursday. And then we'll meet again on Friday for the exam for chapter 12. Okay, so chapter 12 exam on Friday. We will meet live on Thursday at our scheduled time at 12:05. Okay, we'll meet on Zoom. I'll post the Zoom meet material for you. And then tomorrow I'll post the lecture for chapter 14. And let's hope that we can get through this material today. Okay. Make sure you get the homework done. Set E for chapter 12. That'll be the last homework set from chapter 12. So make sure you get that done. Come on by, get your questions answered. If not, then like I said, you can get your questions answered on Thursday, and we'll do the review the same way. We'll go as long as you need. If you have questions, if you feel like you're pretty good with the material that you'll see on Friday, then we'll be done early. If not, then we'll go the whole period. Okay, so it's going to be based on your questions, and then we'll get through as much as we can. Okay, but like I said, don't wait till Thursday. Come on by today. Come on by tomorrow during our office hours and get your questions answered. Okay. All right, so let's go ahead and let's finish up where we left off with on Friday, and that was with the discussion of this percent yield. We started talking about this percent yield, and I pointed out to you then that this percent yield is a calculation that we do. The calculation, and as percentage, and we recall from our algebra classes, a percentage is just a comparison. It compares two quantities. Okay, so when you take a percentage of anything, it's going to compare two quantities, and out of 100 samples of that particular quantity. And so, what are the two quantities that are being compared in any ratio, in any percentage? It's the percentage. It's the ratio of some part over some whole. So if you take a part of something and you compare it to its whole, that's the ratio. Those are the two quantities that are being compared in this ratio that we call percentage. And we call it a percent because the two quantities that are being compared is going to be compared out of 100. You take 100 samples of something, and you're going to compare the part of that sample out of the 100. Okay, so that is what percentage means. And so when we talk about percent yield in chemistry, the percent yield is going to be the percentage of the amount of product that we form out of the total amount of product that we expect to get. Okay, so the two quantities that we are comparing in a percent yield in this particular percentage then is going to be the part here, the part that the quantity that we refer to the part that is what we call the actual yield. So that's the part, okay? And the theoretical yield here, that is the whole, okay? So when we talk about the percentage here, we are still comparing part to whole, okay? But we call it actual yield and theoretical yield. What these are, we'll talk about in just a moment, but understand then, if this is a percentage, we're gonna take this ratio here, this ratio of the actual yield, the theoretical yield, and we gotta take it out of 100. So we're gonna multiply it by 100, and there's where we get our percentage from, okay? Now, the percentages that we will deal with then, and make sure you understand this, the percentages will never be 100%. So when we talk about percent yield, when we talk about the percentage in chemistry, the actual percentage, and I finished up with this on Friday, the actual percentage never ends up actually being 100%. And actually, if it ever gets to 100%, then as chemists and actually as scientists, we use this percent yield in other fields as well. But as a chemist, you look at that percentage and we ask ourselves, what went wrong? So therefore, if ever we achieve 100% yield, if ever anyone achieves 100% yield in real life in laboratory work, everyone else is going to look at that and ask themselves what went wrong. And there's a reason for that. And there's actually a few reasons for that, and we'll talk about that in just a moment. But do understand that we will never actually get 100% yield, which means then, if you think about this, if that's true, then the actual yield here, the part, will always be less than the whole. And that's what we expect to happen. So typically in lab, we look at the percent yield, and we use the percent yield to determine how well we did our work. But it also allows us to understand then how good was the reaction itself. Was the reaction a viable reaction, or are there other things going on that is making this percent yield a little bit lower? Okay, and so typically the percent yields are used to determine how well we did the work, how good the theory is, and then also or what we can do to make increase that yield. I mean, we never expect to get 100% yield, but the goal is to get as close to 100% as possible, and to examine the chemical reaction to see why we're not getting as close to 100% possible. Okay, so this percent yield is an actual number that we calculate for, and it's a good number that we have to be able to use in order to determine how well we did our work. Okay, and so with that said, then what are some reasons then why, what are some reasons why we don't get this 100% yield? Okay? Well, before we get to that, then let's talk about then what a few of what these quantities mean. Okay? So we talked about the percent yield as being the actual yield over the theoretical yield. Okay? So the theoretical yield then here, if we take a look at this, it represents then the ideal. Okay, this is the maximum amount of product that we would get. So you got to make sure you understand that this represents the ideal amount, which means then if everything went perfectly, and I'm sorry, this is my board, my drawing board's a little off today. Okay, so this represents the ideal amount, meaning then that if we live in a perfect world and everything was perfect and we did everything perfectly, this would be the amount that we would expect to get from a chemical reaction. Okay, if everything went perfectly. Okay, so this represents the maximum amount of product that forms. Okay, so this represents the product forms if the reaction is run perfectly. Okay, this is the maximum amount. Okay, so again, because we never get 100% yield, we never expect to get this actual yield. Okay, so this then represents the upper limit. Okay, this is the maximum amount that is expected to get from a chemical reaction. Okay? And folks, how do we get this theoretical yield? We already talked about that. Okay, so this theoretical yield is the calculation that we did, the stoichiometry, okay, the stoichiometric calculation that we've done already. Okay, where we had calculation, where we calculated for the limiting reagent, and then we calculated based on the limiting reagent the maximum amount of product that we expect to get. What we've been doing up until that point, that is calculated for theoretical yield. So we can obtain this number. So make sure you understand then that when we talk about the theoretical yield, and I want to highlight this point here, this is a calculated, this is going to be a calculated value. We have to get this value. Okay, so we obtain this value by doing the stoichiometry down here. It is a calculated value. It's a number that we have to obtain. Okay, it is not given to us. Okay, so we have to be able to calculate for it. So make sure you remember and recall how to calculate for these theoretical yields, and we're going to review that as we go through some of these problems. Okay? The actual yield, on the other hand, then, when we talk about the actual yield then is the, let me go ahead and do this here. The actual yield then is the amount that actually forms in the lab. Okay, so it's the actual form, the reaction, when the reaction is carried out in the laboratory, This is the amount that is obtained. This is the measured amount. Okay, this is the amount that we actually obtain from when we run the reaction. It's measured. We do not have to calculate for this. Okay, so we do not calculate. Oops, sorry. We do not calculate for this value here. Okay, we do not calculate for this. We just have to identify this. We do not calculate this amount. We just have to identify it in the problem. So we won't be running these chemical reactions. Okay. Unfortunately, given the circumstances the way they are, we won't be able to run this reaction. But if we were in lab, if we were in class together, one of the labs we would run, and I talked to you about this when we did meet, one of the labs that we would run then would allow us to calculate for this percent yield, because we would run the reaction and we would get the actual yield. We would weigh out the amount of product that we get. We would get the actual yield ourselves. And so again, this is not a quantity that we calculate for. That would be the theoretical yield. We obtain this value either by running the reaction itself and weighing out the product, or measuring out the volume, or whatever we need to do. But we will obtain this by running the chemical reaction. Okay, so we don't calculate for this. So for our purposes, since we don't get a chance to carry out these experiments, we have to identify the actual yield in the problem itself. So it would be given to us. We do not calculate for it. Okay? It is given. So in the problems that you will do tonight, okay, for your homework, this yield here, this particular quantity has to be given to you. Okay, so make sure you are able to identify this particular value here. Okay. All right. So with that said, then, since the theoretical yield, since the percent yield is always greater than theoretical yield, since the percent yield is always less than 100, this number must always be lower than the theoretical yield. It will always be lower than the theoretical yield. Now, occasionally, in real experiments that we run, occasionally you'll come across a situation, if you continue on this, where the actual yield here is greater than the theoretical yield. And so you get a percentage that is greater than 100. And so it's at that point where you have to really stop and think about what's going on here. And this is an issue that does come up every once in a while. And when you have to be able to resolve that issue by thinking about what is going on at the chemical level. What are the substances doing that will result in a product that is greater than what you expected? Okay, and so that's something that you consider that we do later on in a higher level chemistry class. But that's something that does every once in a while does rear its head. Okay? All right. So, like I pointed out, what are some of the causes then of what would cause a percent yield to be lower than 100%? Okay. Well, first and foremost, then what you got to make sure you understand is that the reactions may not be done. We assume that when you mix two compounds together, when you mix two substances together, that it's always going to run to completion. That means when you put them together, that it runs and you use up all the reactants and then you get your product. Okay, that's not always the case. If you stop the reaction too soon, or if you prevent the reaction from running completion, then you don't get all the product that you expected to get. And so the reaction then forms less product than what you expected. The percent yield goes down. Okay, so that's one case. Typically, though, we don't run into this issue too much. Not in freshman level chemistry, not in high school level chemistry, and definitely not in freshman level chemistry in college. But this is an issue that does plague a lot of labs as you go higher and higher up in your chemistry career. Okay? All right, so that's one reason. Okay. The second reason that becomes more of an issue here is you use what you're using has impurities in it. It's not there's contaminants in your reactants. That means then, for example, you run your reaction, and remember I always tell you don't ever pour the reactants back into the reagent bottles. If you do, then you're introducing impurities. And if you have impurities in your reactants, that means your reactants aren't pure. There's a possibility that side reactions that will occur that you don't anticipate that will take some of those reactants away, and then you end up again with less product than what you predicted. And so if you start out, excuse me, if you start out and your reactants are not at what you expect them to be because there are other parts in there, there are other impurities in there, Then you'll get secondary reactions. You'll get side reactions that you didn't plan for, and those side reactions will form products that will take away, that will remove some of the reactants that you were hoping to use to get to your product. And so with that said, then that will also lower the actual yield and thus lower your percent yield as well. Okay? All right. You lose some product. Now, again, this is an issue that doesn't arise too much in lower level chemistry. This arises in higher level chemistry where you have to run two reactions at one time, two or more reactions at one time. And as you do so, you take the product from one reaction and you use it for another reaction. Okay. And so during that process, then you're going to lose some of your product. And if you lose some of your product at the very end of the process, when you finish running all of those reactions that you were using to get to your final product, at that point, then you'll end up with less product than what you anticipated. Again, because you've lost it as a result of these transfers. Okay, so again, this issue here does not arise in lower level chemistry. This is something that comes up in higher level chemistry. Okay? All right. The last two, though, do come up quite a bit in all levels of chemistry. Okay, and that is you expect something to happen. You have your recipe there, you have your equation, you've done all the balancing, you did all the work, you found out how the reaction runs, and then you find out later on that the reaction doesn't quite work out the way that you expected it to work out because the theory doesn't fit the practice. That means that even though you say that you mix together these two reactants and you expect to get this product, that there are always going to be something else that happens. Okay? There are side reactions, and I've left that out of this particular slide here because that's something that higher level chemistry classes have to deal with. We don't have to deal with this here because that kind of muddies the water a little bit here for us. Okay, so we only focusing on what possibly could happen. But this bullet point here that I just pulled up for you really deals with that you expect a certain only one type of reaction to occur, but there could be a number of side reactions that occur as well that we don't anticipate for. And if that happens, again, that kind of comes back to what we were saying here with impurities here. If you get side reaction, those side reactions are going to pull some of those reactants away, making other types of products. And so because you did not plan for those other products, because you didn't realize that those reactions are running, okay, then your product, what you thought would form, doesn't actually form. So you get less product than what you planned for. Okay, so the reactions don't follow what you had expected to happen. They don't follow the theory. Okay, so that happens quite a bit. That happens quite a bit in all levels of chemistry. Okay, and so it's just something that we learn to deal with as we move up the ladder, as we move up our experience of chemistry increases. We start thinking in terms of other possible side reactions. Okay, so this is where we start talking about, and I'll write this in here. This is where we start dealing with side reactions. Okay, and these side reactions, okay, are reactions that occur that we do not anticipate. Okay, so these are where the side reactions come into play. Okay. All right. So with that said, then the last issue is something that always arises in all levels of chemistry, and that's human error. Okay. You make a mistake in calculating, you make mistakes in your transfer. And so human error really plagues the process of running chemical reactions. And as a result, then your actual yield then is going to be much, much less than your theoretical yield because of human error. And this is something that is always going to be a possibility when you run these chemical reactions. All right. Let's go ahead then and let's talk about how we calculate for these percent yields. I'm going to go through these steps with you really quickly, but again, make sure you understand that as you work through these here, you don't have to memorize these steps. You just make sure that you practice these problems, practice them today, and if you do, you'll memorize these steps. Okay, so always make sure again you get the balanced chemical equation. Once you have that, in order to get the percent yield, we need to figure out which one of the reactants run out first. So we need to obtain the limiting reactant. So the second step then, making sure that you obtain the limiting reagent here. Okay, so you got to be able to calculate for that. This represents then the first calculation that you have to do when you do percent yield. And you're going to find then the percent yield represents basically three calculations, three separate calculations you have to do in this one calculation. Okay, so once you have that, you want to calculate for the amount of product. Okay, so you want to calculate for the amount of product. This is calculation number 2. This is the theoretical yield. This is the theoretical yield calculation, and where you are calculating for the theoretical yield. Okay, once you have that, you have to ID, you have to identify this from the problem. Hopefully you do this at the beginning, and I'll show you how to do this, okay, from the problem. And then finally, you want to make sure that you divide the actual yield by the theoretical yield, and this represents then, this last step here represents the third calculation in this process here. So in order to obtain the percent yield, you're going to be doing at least 3 different calculations. Okay, so let's go ahead then, okay, and let me go save this really quickly. Okay, and let's work out a problem together. Okay. All right, so let's go ahead then, and let's take a look at this here. So we and I'm running out of time here. So what I would like you to do for tomorrow, and again, so we'll finish up tomorrow. Okay, what I'd like you to do for tomorrow is work out this problem here. Okay. What they're asking you to do here is find the theoretical yield. Okay, I give you the equation, check to make sure that it's balanced. Okay, and so find the theoretical yield of this product here, of calcium oxide. Okay, okay. And let's go ahead and do this of calcium oxide. So they're asking you then. So if you have this amount of calcium carbonate, okay, find out how much calcium oxide forms. So I would like you to work this out, folks. Work this out for tomorrow. Make sure you submit it today. Okay, so make sure you work it out and then submit it online. This is the only problem that I'm going to ask you to do for today that you have to turn in, and then save it, and then tomorrow I'm going to start with this problem here. Okay. One question I have for you before we finish up here is that I told you that you'd have to do the limiting reagent. Okay. Why don't we have to calculate for the limiting reagent in this particular problem? Okay, think about that, okay, and then I'll answer that question for you tomorrow, but make sure then that you get the theoretical yield for calcium oxide, okay, so make sure you type the answer into Edpuzzle, show me your work, scan it, okay, and then show me your work, and then we'll start with this problem tomorrow, okay. All right, folks, have a good day, and I will see you tomorrow.